Hello everyone, welcome back. In this topic, we'll cover autoscaling. You have to use autoscaling with load balancer only, come what may. Load balancer and autoscaling together make each other complete. This is our agenda. We'll have a pre-autoscaling talk, then we'll discuss about autoscaling, launch configuration, autoscaling groups, and finally conclude this part with dynamic scaling. Let's see what scaling is. We have the same website as we had in load balancer, and this website has a global presence, amazon.com we are talking about. There is a server which hosts this website. After announcing big discount, number of users log into Amazon website increases, which means to have the application or website up and running will need more compute power or more servers. And when the number of user connection decreases, there's no point in running so many servers. So we decrease them to save money. We have seen similar kind of architecture in load balancer also. But in that case, we had to have maximum number of servers or EC2 instances up and running all the time. Even when user connection decreased, we did not have any way to reduce the number of EC2 instances. This addition and removal of servers or capacity based on workload is called scaling. Scaling is adding or removing capacity or resource as needed. Scale out is adding capacity or resources. When the number of servers got added up, that was a scale out event. Scale in is removing capacity and resources. When the servers were removed, that was a scale in event. There are two types of scaling, vertical and horizontal. Let's see the types of scaling. We have two types of scaling, vertical and horizontal. First, vertical. Let's say you are running your application on a server or machine which has 2 GHz of CPU. But because your application load has increased, you have to increase the CPU capacity to 3.2 GHz. Or RAM needs to be increased from 1 TB to 2 TB. Or network bandwidth from 4 gigabits per second to 10 Gbps. This is how you do it. Make the server bigger, which means add processing power or RAM or network interface cards to the same server. This is called vertical scaling because you are adding resources within the same server. What if you need more power? Let's say 10 GHz of CPU and 8 terabytes of RAM. There's a limit to which you can add resources to a single server, beyond which you cannot increase. Let's see horizontal scaling now. If you have to increase CPU power, just add more servers. If you need 3 GHz of CPU, add 3 machines, each having processing power of 1 GHz. Similar is the case with RAM or other resources. We have a similar server as earlier. This time, to add more resource, we just add more servers. This is called horizontal scaling. The advantage is that you can have unlimited amount of capacity. Autoscaling is the same scaling process which I just said, but scaling happens automatically. One very important thing, AWS autoscaling only uses horizontal scaling. It does not use vertical scaling. If you have to do vertical scaling for some reason, suppose you want to increase the RAM or CPU power or network bandwidth, then you'll have to change the instance type. But as far as autoscaling is concerned, you can only add additional EC2 instances. That means adding more servers in the current existing stack. That is horizontal scaling. Autoscaling is scaling out or in automatically without any manual intervention. It helps to ensure correct number of EC2 instances are available to handle load. You'll never have capacity issue or no downtime whatsoever. Multi-AZ EC2 instances provide high available solution. This is pretty obvious. This is a group, we'll call this autoscaling group, where you have a set of EC2 instances running. All have the exact same application in them. If one or more EC2 instances go down, autoscaling will launch a new instance with the same application in it. Autoscaling can dynamically increase and decrease capacity as needed. In the previous slide, I mentioned that autoscaling would launch a new instance with the same application. How does it do that? Thanks to launch configuration. Launch configuration is a template that is used to launch EC2 instances for autoscaling purpose. You'll see how familiar launch configuration is to you. This is the template. It contains AMI ID, instance type, key pair, etc. I hope it's ringing some bells. These are exact same parameters which you use to launch EC2 instances. In launch configuration, we keep all those configuration in a template rather than launching EC2 instances with it. Autoscaling group uses launch configuration to launch instances. Launch configuration cannot be modified after creation. If you want to change something or modify the launch configuration, then you will have to create new one and attach it to the autoscaling group and remove the old configuration from this group. It can be created in two ways. From scratch, that means you have to mention the image ID, instance type, storage devices, etc. Or it can be created from an EC2 instance also. Attributes from the instance are copied over. Block device mapping of the AMI is included. Any additional devices which were attached after launching the EC2 instances are not considered in launch configuration. Let us create a launch configuration from scratch and then from an existing EC2 instance. Go to the EC2 console and on the left pane, you'll see something called auto scaling. Here, you have an option of launch configurations. Click on Create Launch Configuration. This is already a familiar screen, but this time, instead of using AMI from here, we'll use our own AMI. We created this AMI which has Apache already configured. Select this AMI, click on the instance type, give it a name. Do not bother about advanced details. These are something which should be taken care of by Unix admins, or you'll ask their input to provide the kernel ID and RAM disk ID. Click on Add Storage. It is exactly similar as we did while launching EC2 instances. We'll not be adding any additional volumes, just the root device. We'll select a security group for our VPC. In this case, this security group, which is wide open, belongs to our VPC. Click on Review and then Create Launch Configuration. At the end, you'll have to mention the key pair. We'll use the same key pair as we have been using in all our demos. Click on Create Launch Configuration. Your launch configuration has been created. Now if you see, no EC2 instances were launched. All the parameters which we chose were similar to that of while launching an EC2 instance. So the launch configuration has been created. In the Details tab, it will tell you what we have chosen. This is the AMI ID, there is the key pair name, the security group, the instance type, and other information. That's how you create a launch configuration. Just now, we have created a launch configuration from scratch. Now, we'll create a launch configuration from an EC2 instance. So this is the EC2 instance which is up and running. And these are the configurations for this EC2 instance. It has an instance type of t2.micro, has a default security group, key pair name, has the same key pair name which I've been using so far. It has only one block device, which is the root device. So we'll create a launch configuration from this EC2 instance. However, you cannot use the console. You'll have to use command line interface to create a launch configuration from EC2 instance. This is the command we are using to create this launch configuration. Don't worry about the command because we have a separate session on CLI. The command is an autoscaling command, and the name of the command is create launch configuration. The name of the launch configuration is launch config from EC2, and I'm providing the instance ID. This is our instance ID, this one. So we are creating this launch configuration from a running EC2 instance with ID of this. Press enter. It takes some time to create the launch configuration, but once it is done, you'll see that the launch configuration has been created. So it was done from a running EC2 instance.